Okay, so in looking with problems that deal with the heat conduction equation, there are three questions that we can ask that can help us to simplify the problem and reduce it into a form that we can solve. The first is which coordinate system is most appropriate. So our choices are Cartesian, cylindrical, and spherical coordinates. So maybe if you want, you could pause the video here and think about which coordinate system you would apply to this problem. Okay, so the rod is a cylindrical rod. It has cylindrical symmetry that suggests a cylindrical coordinate system. I think we can probably agree on that. So no surprises there. The second question to think about is in what direction the heat is flowing. So maybe stop the video here and think about that. Okay, this is being heated internally. That's one clue. Another clue is the temperature distribution that we're given. Shows temperature varying in the radial direction. In other words, as we go from the center line to the outer surface. The other clue is that for the purposes of this course, we're only looking at one-dimensional heat flow. So taking all those things together, it suggests that the heat is going to be flowing in the radial direction r. Okay, the third question that we can ask is what direction is the temperature varying? In other words, what direction is the temperature gradient going to be happening, because that's the driving force for heat flow. So maybe stop the video here and think about that as well. Okay, we know that the temperature gradients are the driving force for heat flow, and the heat flow is in the radial direction. We already determined that. So it makes sense that the temperature is going to vary in the r direction. And we already have a clue for that again from the given temperature distribution, that that is a function of r. So the temperature is going to vary in the r direction. Okay, this information then is going to be very helpful later on as we try to analyze the problem further.